So in this problem, it's asking one side of a right triangle. So let's draw a right triangle. Is known to be 10 centimeter, and that's the side that is exact for math. For calculus 1, we need constants and variables. Then the adjacent angle is measured at pi third. So this is the angle theta, and theta is being measured at as pi third, with pi third radians with a possible error of pi 15. So the absolute error of measurement of theta is going to be pi over 15. Now it's asking use differentials to estimate the absolute and percentage error. So error in computing the length of the hypotenuse. So let's see, this is the hypotenuse, and we want to use the differentials. So what is the formula for differentials? And this was the formula that we used a bunch of times. And so in here, the first thing that I want to do is to basically find that function f, so I can take the derivative and form the differentials. And then the second thing that I want to do is find that the input value that makes the function work. So first thing first, how do I find a function? Function has to connect basically h and theta. So let's see if I can do that. In here, what I observe is that 10 over h is equal to cosine of theta. So 10 over h equal to cosine of theta. That means that h is equal to 10 over cosine of theta. That means that h is 10 secant of theta. So I found the function h of theta equal to 10 secant of theta. Now I have to find so that's the h, and I have to find h prime. So h prime of theta is going to be 10 derivative of secant theta, which is secant theta and tangent theta. 10 secant theta, 10 theta, basically. And so the next step is, now that I have 10 secant theta, 10 theta, I have to find a value to plug in. So what do I find for plug in? And that's the measurement of theta that we know, basically, that we did measure. And so theta equal to or theta 0 or a, or however you want to call it, theta 0 is equal to pi third. So those are the information. Now we can plug in. And so one thing that you can compute is h of theta, then h prime of theta, h of theta 0, I'm sorry, h prime of theta 0, the two things. This is going to be 10 secant of theta. That one is 10 secant of pi. I'm sorry. What is theta 0? Theta 0 is pi third. So secant of pi third, secant of pi third, tan of pi third. And this one is just the secant of pi third. So now I need to figure out what the secant of pi third is, what tan of pi third is. And let's go down to the table for sine and cosine. So this is the ones that we want to memorize: 0, pi 6, pi 4, pi third, and pi half. And there's a way of memorization. It's the square root of 0 over 2, then square root of 1 over 2, then square root of 2 over 2, then square root of 3 over 2, then square root of 4 over 2. And the first one is just 0, the second one is 1/2, the third one is just square root of 2 over 2, square root of 3 over 2 on the fourth, and the last one is just 1. And then you reverse the order, and then you start from 1, square root of 3 over 2, square root of 2 over 2, 1/2, and 0 for cosine of theta. Now, all I need here is this row for pi third right now. What I need is 1 over cosine of pi third, which is going to be, according to this table, is going to be 1 over 1/2, which is 2, and then sine of pi third over cosine of pi third, which is going to be square root of 3. So now, secant of theta, secant of pi third, secant of pi third is equal to 2 tan of pi third equal to square root of 3. And let's go back up there and put it on. Over here, this one is, that makes it 20. So this value is 20. And this value is 10 times 2 times square root of 3, which is 20 square root of 3. Okay, now I have both h and h prime at pi third. What I need to find is, first of all, is the absolute error, which absolute error is going to be the absolute value, is approximated by absolute value of df, which is equal to f prime or h prime at pi third times delta theta. And h prime at pi third is 20 square root of 3. Delta theta is the absolute value of delta theta is pi 15, and this cleans up to 4 square root of 3 pi over 3. So that's the absolute error. Now I want to find the basically find the relative error. And so how does the relative error work? Relative error so this is absolute. The absolute error approximates with this. And relative error approximates with that value, 4 square root of 3 pi over 3 divided by the actual value of the function, which is h of pi over 3, which is 20, divided by 20. And so we clean this up. Oh, what we forgot to do is that centimeter. And over here again, when you do the division, it's going to be square root of 3 pi over 15. And so when you figure out what it is, it's going to be equal to approximately 0.36, which is multiplied by 100. This is 36.66, which is 36.6%. Oh, this measurement is not very good. So having pi 15 error in that measurement is not going to give us a good, basically approximate. It's not going to give us good measurement, output measurement. So we need to measure the theta at all better, basically.